Hi everyone, in this video we're going to talk about testing in Golang, and basically my main idea about this video is to show you more technique or more interesting technique when you run your tests to get a better result and more understandable result. So yes, we all know pretty much how to write tests, but I'm gonna go through I'm looking at it from a different aspect to just see how we can just run our tests differently and get a better result, and also talk a little bit about testing as well. So let's dive in and find out what can we do. Basically, as you can see, I'm using Go version 1.19, and from here I'm going to just start writing some tests. So because I'm using Go mod or modules, I can create a package. I'm going to call it magical. Inside here, if I'm going to write any test, then I need to create a file. I'm going to call it, for example, other underscore test.go. So as you know, here we have the convention. The convention is every time you write a test file in Golang, it should end with underscore test. So now I'm here, and if I'm going to write a package name, as you can see, Visual Studio Code is smart enough to just guess two things. It's either magical or magical underscore test. There is a difference. The difference is magical is a white box testing, means if I have other functions, then it has access to those functions in the same package. And magical test is black box testing, so it doesn't have access to any private functions. What do I mean is this one. So let's call magical. And inside here, I will create another file. I'll call it other.go and paste some code. So we are in the same package, magical. Something is private because it's start with the first letter is small. Do something else is public because it's just start with a capital letter. So inside here, because I'm using magical, now I have access to something. But if I'm using magical underscore test, which you will see in a few seconds, I don't have access to it. But let's just stop here and see what can we do from other and other underscore test. So if you're going to write test, it will be pretty much the same thing. So you start with a func, but the next convention would be you start with test, capital test. So with the capital T, and then again another capital things what you're going to test. So let's we have our function, so let's test something. It doesn't make sense, but let's just do it now here, and we're gonna just rewrite this one, to be honest, in a few seconds. And so I'm gonna just open up and close the curly braces. Test something, or the function test, it will accept an argument. It will be T, which will be a type of a pointer to testing dot capital T. So that is the whole convention you need to follow if you're going to write some test. Because we are using package magical, now I have access to, for example, something. And let's say, for example, and now we can just quickly check if they are exactly the same thing. So I'm going to say if got not equal to expected, then now we have access to T. So I can say T dot errorf. Now we are running our test and we will make sure if it passed or not. But as you can see, to begin with, we have access to something because the package name is correct. So let me just quickly copy this one and paste this one, and just let's call it do something else. So here I will call do something else. Actually, what was the function? This is the function name. So let's call it here do something else, and I think this is returning false. And now if I go to cd packages, actually cd magical, and then here I do go test dot, you can see basically everything was okay because we have the same package name. so I have access to them. But if I want to use the magical underscore test or black box testing, the first thing you can see is that we don't have access to do something. So I'm gonna just, well, we need to import something now. So I'm gonna call it magical, then dot. So magical that do something exists, but if I want to do magical, then dot, something doesn't exist because something is private. If you want to know more about the functions, private, public, I will just put the link here so you can also follow that one and understand how it works. But basically, if the first letter is small, it's private. If the first letter is capital, is public. So you can see now what is the difference. So here is a black box testing. You don't have access to the private one, but with the white box, you have access to both of them. So, and now this one doesn't exist. I need to remove it, and we don't need to care that much. The next thing is, as you can see, so we have got, we have expected. So it's just two variables. I'm just defining, I'm running my functions and make sure, like for example, this is what I got and what I expected a false here. And then I will double check if they are equal. So Golang by default in a standard library, it doesn't have the assertion library. So you need to really know how to write Go code, which is, that's what we do. And it's just a very simple if statement. So if what we got and what we expected are not the same, then we are going to use t.errorf. So t.errorf is a way of just saying to the our test what happens. Error means something's happened and they're not, basically if the condition is not correct, so there is an error and our test will fail. So if I make this one true here and then run our test one more time, you can see the test failed, didn't get expected result. Wanted true, got false. Okay, so we got false here, but we expected true. Okay, so we can move on. This is just the gist of it, and if I want to just change it a little bit, that's what we can do. So for example, I'm gonna move here, created this one, I am gonna just test at, so the same thing here. So 2 plus 2, I don't know, 3 plus, let's say 5. We expect this one to be 8. And let's see this one. I'm gonna make this one false actually. So we can just have 2 tests here. This is fine. And if I change this one to 10, so basically we know 3 plus 5 is 8. So, but we expect 10. So I'm just gonna make it false, or we're gonna make it errors. And then you can see what do we get here. So we have a test which was failed as well. And if, for example, you are writing this test and you don't want to really work on this one because this is just something and you want to skip it for whatever reason, you want to focus on different tests, that also is available in T. So we have T, then dot, skip, as you know. So we have skip, skip F, and everything else. So I'm going to skip it and just say we will ignore this test for now. So now we know this test fails, but because we are skipping it, if I just do go test dot, everything is passed because it skipped this test. And the reason that you don't see this message, because we are not running it in verbose. So if I do go test dot dash v, now you can see a different thing. So we run test something else, which was this one, and it passed. It took, for example, this amount of time, which is nothing. And then we wanted to run test add, but it got ignored because of, it just skipped because that was the message we passed here. So if you want to know more about your test and the result, you're gonna pass dash v. Okay, so this is quite simple, but I want to talk a little bit more about other type of testing we can write. So I'm gonna close these two, clear the terminal. As you can see here, I've also created a file called calculator. So there is a package called calculator, and we have this file as well. and it really does nothing very specific. It just adds something, subtract, multiply, and then divide something, and then also we have operator, so you can just create higher order function and then based on this one, so it's a function which returns a function, so you can just, for example, create or just add something. Sorry, if you pass the sum operation, it will return the sum function. So that if you call the operation with the add, then it will give you add, and then it will give subtract, multiply, and other things. But the aim of this one is just really to give us something to work. And now here I'm going to create a file called calculator underscore test.go. So this is the main file that we are going to use and also benefit from that. Like always, the package would be calculator, and then I will start with the func and test, and now I'm going to test the, for example, sum function. So we have it pretty much the same thing here. If I go here, I'm going to copy exactly this one because they're exactly identical, and so we're going to test the sum function. Let's go there and paste it here. I'm going to save it. It will import testing. Let's just use the proper name here. So we are testing sum. I'll ignore this one, and here what I'm going to just call is the sum function, and I'll pass, for example, 3 and 6, which will be 9, and expected result would be 9 as well. So we are using actually float 64 and expect float 64. So let's just quickly do that, and I'm gonna use everywhere the same thing. So the error is gone, and now if we run our test, we should get the same result. So just one thing to know: if you want to run the whole, well, every test you have from the root directory, so it's our root directory now here, all you have to do is just to do go test dot, sorry, the dot slash 3 dots, so dot dot dot, and it will run the whole test suite in our project. So as you can see, it went to the calculator, and it also run the magical one. Magical one is cached, so it's good because nothing has changed, so it doesn't have to run it again. But the idea here is we could run everything. But if I want to run specifically a test in a calculator one, then it's also doable as well. And the package is calculator. So I'll say calculator. So now it only run the calculator one. And if I want to run the magical one, so all I have to do is to say magical, and you only run the magical. So if you're going to run a specific one, you're going to say go test and the package name. If you want to run everything, it's just go test and then this format, so dot slash dot dot dot. So that's a handy one if you're going to just do it as well. In this case, if I want to run the whole test in my current directory, then all I have to do is to go to the directory, which is calculator, and then go test. So go test, now you only run all the tests in the current directory. Bear in mind, all of the tests should end with underscore test. Okay, so some just handy commands here, but the whole idea is now to run test command, which we could run it and everything is fine. Let me also run one more test, or add one more test, then we can just play along with those. So here we have another test for the subtract, and then if I just do go test, you can see now if I do go test dash v, you can see it run the test sum and test subtract. Okay, everything is fine, but how about if I want to use some regex? So it would be also very simple. If I only want to run a specific test, so we learn how to skip it, so t.skip. But the next thing that I want to do is just to specifically run, for example, with regex. So all I have to do is to say go test dash run and then give the regex. So now it only run the sum. So if I make this one fail, let's put this one 6. Now we know if I just do go test one of the tests fail. That's good. Now if I do with the regex, because I'm only running a test which just has the regex sum, then it will ignore the subtract and it doesn't run the subtract. So I'll bring this one to 5. So we have all the passing tests here, but this is just how to run tests with the regex. Okay, moving on. Now I want to talk about the coverage. All I have to do is I'm gonna go back here. So I'm in a root directory, and all I have to do is to go test-cover. Basically, what do we want to run the test? So it will be, I want to see the whole test. So we're just saying go test all of the tests, and then we're passing the parameter of -cover. So if I press this one, you can see some result now. So let me just bring the terminal down and then do the command one more time. So you can see we have a coverage of 15%, coverage of 50%. And now if I go to the, for example, for the calculator, we know because we are only testing the sum function and subtract function. So we have quite a few other functions which are not. So for example, multiply, divide, and operate are not covered at all. So that's why we're getting, like, for example, not enough coverage. And if we go to the other or magical package, so here we have test something else, but we are not testing the something function. So because here is private, we are not testing this one, we get 50% because only 50% we have the coverage. But this is a very small project, it's easy to understand. But how about if it's bigger? How we can get a better understanding of, like, the coverage? That's what we're gonna do right now. And in order to get a better understanding of our coverage, what we have to do is to just say go test everything, and now we are just outputting the coverage to coverage.out. So we are passing cover profile, then coverage.out. And if I call this one, you can see we get the same result, but this time we have a new file. It's coverage.out, which is give us like something like this. It's not easy to understand, but we're going to use Go tools to just get a better understanding of what is actually happening. So now we have this file. Let's just go and get, we have the coverage.out. Let's go and get some like meaningful result from here. In order to do that, we're going to say go tool. So go to cover -func, and now the address of the coverage, so which is coverage.out. If I open this one, now we will get a better understanding. So the sum function from the calculator has 100% of coverage, subtract has 100%, multiple, divide, and operate has multiply has 0%, so it's good. Do something else has 100%, and something has 0% because it was private. In total we have 20%. So now it's a little bit easier to understand what is happening. But again, if we have like lots of functions, again it would be quite difficult because like it would be a very big list. You need to go through them one by one and it might take time. So we have another option, and it's just to see it in a browser. So exactly the same thing. Instead of func, I'm going to pass HTML here. And now it's much better because now it's more visible and it's just in a browser. You can go inside different, for example, packages and different files and see what has happened. So for example, if I go to other, you can see we are covering this one. So we have covered the green one. And obviously they don't track like the initialization or package or imports because we're not really testing these things. We are testing the logic of the code or the business code. And you can see we are testing this one, but we don't test do something. And the next thing is, if I go to calculator, you can see we are testing sum, we're testing subtract, but we don't test anything else. So here with the HTML, we are getting a better understanding of what is happening. So I'm going to put this one down, but just to make sure you understand, if you want to see it in a terminal, you can say go tool cover dash func and then the coverage.app, the file we just generated a few seconds ago. But if you want to see it in HTML, you're going to say go tool cover dash HTML and then coverage.out. So HTML and func are the different one. But here is not the end of the story. We have other things as well. But before just seeing that, let me just add one more test, which is, okay, I am going to make this one smaller. So here we are in our calculator test, and we are running our test. Just for example, we are testing the sum function once and subtract function one more time as well. And if I want to see how many times I have been testing sum functions and how many times I've been testing subtract function, also we have that for that one in Go as well. All we have to do is to run the Go test, all the files. We are generating cover profile, which will be coverage dash count. But here the cover mode is the count. So how many times, or the count of a function has been tested. So it will be relative, but you will see the output in a few seconds. So I'm going to run this one. We're going to get some results again. Now we have coverage dash count dot out, and if I do exactly the same thing, and I think it's here. Sorry, no, I just need to do the coverage dash count dot out. Now you can see we are saying low coverage and high coverage. So it just, the color is actually changing, if you can notice, from, for example, gray, and then go just less green, and then it will go to the very high coverage, which is the just brightest one. But because we are just calling these two ones, you don't see the difference at the moment, because they both have runtime, and it's just high coverage, or just comparing with others, it's just the highest. And if I just zoom out a little bit, but now we're going to do something else, and you will see what do I mean. So if I call, for example, subtract 2 times, then there will be a difference. So here it will be 1, here it will be 2 times. So 2, we're just calling subtract more, and the result would be different. In order to do that, we're going to just introduce table-driven design. Table-driven design is basically just a fancy name, but what we are doing is, instead of, for example, calling this subtract one more time, we can just call the subtract with multiple input and multiple expectation, and then loop through them, and then still one test, but there are multiple assertions. So what do I mean is basically very simple, and that's what we're gonna do. So here we go. So we have test, subtract, table driven, and it's pretty much the same thing. So we have some scenarios. So the scenario is we have a number 1, number 2, and what do we expect? And it just array, or well, it's a slice basically here. And you can see I'm just passing, for example, 20 and 7. I expect 13 because we're going to use subtract, and then this one and the other one. And all we are actually doing, we are just looping through the scenarios, subtracting number 1 and number 2, and then we're making sure if what we get and what we expect are, if they're not the same, let's just error and move on. So let's see exactly what's gonna happen. To begin with, all I'm gonna do is actually run the test to make sure everything is fine. So go test, actually here, yes, let's just run everything, why not? So in the calculator, everything is fine. If I want to see it in verbose mode, you can see. So here we are running the sum, subtract, and subtract table driven. Everything is fine. Calculator is also just doing something. So everything passed in the calculator, and it will go to the something one, and that one also was fine in the magical here in a magical package. But what I'm trying to get now is a different thing. So I will now go here again one more time. We're running our test. We will create a profile, coverage profile, and we will call it coverage profile, coverage count let's call it 2, and then cover mode would be count. So I have this one. Our coverage has not changed because basically we are not really doing anything different. We're still just testing sum and subtract. But here, if I just go and check with the go tool, if I check the coverage count 2, now we will get a different result. So if I zoom in a little bit, you can see we have, so the red one is the one which doesn't have coverage. So nothing has changed on that side, but you can see now the sum function has less coverage or low coverage, and the subtract has more coverage because obviously we are calling it a few more times, and nothing has changed in a other because it's exactly the same thing. But here you can see if you compare, for example, sum and subtract, sum has been only tested once, subtract was tested 4 times. So this is just also another fancy things, or also interesting things that you can leverage or you can use when you're going to run your test to just check your coverage there as well. And if you want to know more, and all you have to do is just to say go help with test, you're gonna get, for example, a very good like introduction of how to write tests, how you're going to, for example, the conventions that we were talking about and everything else. But there is one more thing that I want to talk about, is this one. So here, for more information, you can just say, for more information, you can just say go help test flag. So if I go help test flag, we will get more information. I'm gonna just put this one, for example, here in a file, call it test flag test_flag.txt. So basically, instead of like showing the result in a terminal, I'm just going to output it in a file called test_flag.txt. And now I have, if I just go here, I have test_flag.txt, so it's just the whole things. And if I scroll down, you can see, for example, what we were just talking about. So we had cover mode, we have cover, we have count, and we have quite a lot of other things if you want to check them. We've just gone through some of them, but there are definitely more. Okay, so far, what did we learn? We learned how to create a test file, which is going to ends with _test, and then we also learned that how to create a test. It will be a function start with test, capital T, and then capital the next letter of the first letter of the test that we want to write. And also our tests will accept T, which is a pointer to testing.t object. And if we're going to we just run our scenarios, and then also we're going to check if the scenario and the expectation are the same, which is good. But if they're not the same, which is here, then our test can fail. Okay, we also talk about a skip. So we just remember that we can just say a skip here, or a skip F if you want to write more stuff. So to skip a test. Also, if you're going to just give extra information, then you can just, I'm going to remove this one. You also can do here, let's go in the table driven one. So if you want to just give more information, you can say t.log, or log f. They're exactly the same. You can just format one of them, the other one you cannot. And here, basically what you have to do, this is a capital L. So you're going to say, this is table driven test. That's what they call it. So here, if you run your test, you can see this log. So if I do go, actually, I'm gonna go to the calculator, see the calculator, and now if I do go test, I'm not gonna see anything. But if I do go test -v, -v, I can see the log. So basically, t.log is just give you a bit of extra information. By default, Go is running all these tests one by one. So if you have like thousands of tests or hundreds of tests, it will be one by one. And then there is also a possibility to run all of these tests in parallel. You need to be very careful if you're going to run your tests in parallel, because they don't have to impact each other. But if you want to do that, it's also very simple. So you're going to say t dot parallel, and then so I want to run this test in parallel, for example, and maybe this test in parallel, and it will be pretty much the same thing. So if I run them, now you're gonna get the same thing. Because we don't have really many tests, you don't see much of different, but you can just run this test in parallel. There are more things that you can do. If I just do t dot, you can see we have cleanup, deadline, error, error f, we have fail, which we will talk about it, or fatal, and then we have helpers, we have log, parallel, and we have quite a few more things. Skip now, skip f. We talk about just some of them are just formats, some of them are here, but if you want to know more, definitely go to the Go documentation and you can find out more about them. The next thing that I want to talk about is here. So we talk about error, but we didn't talk about, because if there is an error, basically our test fail but still continue. So it will report that it was fail, but it will continue, because if you have multiple assertion, then it will do it. For example, I'm going to close this one. I'll go to the sum here. So I have one assertion here. I'm going to do one more assertion. So I'll go say if, for example, 2 not equals 3, then do something. So we know our test, let me just do this one. Yeah, actually I'm gonna say t dot error here, silly assertion. We know 2 and 3 are not equal. But the idea here is, for example, well, actually I'm gonna put this one here before that. Okay, so we are running our sum function, or we are testing our sum, and if we have two assertions, for whatever reason, if you use error, it will just log it and move on to the next one. So let me just tell you how it works. So go test dash run, and let's call the sum one. We are getting that silly assertion and we moved on. The test failed, but we don't know if this one also worked or not. So I'm going to change this one, for example, 3 and 6, I'll put 5. So we will have one failure here and we will have another failure here. So let's run it again. There we go. Now we get both of them. So if we have two assertions, and if you use error or error.f, it will check the first assertion and will also go to the second assertion as well. But here you can just change the fact if you use a different one. So I'm going to ignore this one because that's not what we want to do. And I'm going to give this one a correct one. 3 and 6 are 9. Let's run our test, make sure everything is correct. Yes. So here we have, like, we are testing something else. So we are testing the error, we are testing the fatal, and also errors. As you just saw, if errors happen, it goes to the next assertion. It will continue to running the test. Even though it fails, it reported, it's fine, but it will continue. But when fatal happen, it doesn't continue. It will literally break the test and then doesn't do anything after that. So now I'm gonna just run our test, but here I'm gonna just say fail. So you will run this test only, and I'm going to run it. You can see here we failed but moved on because we're using error. And then we go to the fatal one. So fatal is actually log it, but it doesn't continue, so we don't see this line at all. So we never see this line because fatal will break the test and never continue to do that. So this is just and also important things to know. So if you want to log something, we have t.log. If you want to report error, is t.error. So if you have multiple assertion, you can use error. But if you literally want to completely stop the test, let's say you cannot connect to the database for whatever reason, even if it's mock, you cannot do it, the rest of the test basically is meaningless because you cannot do any assertion and all of those assertions will fail. Then you can use, for example, fatal. So fatal will stop the test and doesn't continue. Okay, in this stage, I think we are just have enough knowledge how to run our test, how to get a coverage, how to check the coverage, different type of coverage, how to run a specific test, how to fail a test, fatal a test, log, skip, run in parallel, and quite interesting and enough information to write any sort of test. This type of test or this type of writing test could be used for functional, unit tests, integration, end-to-end tests, and all of these things, and only using the standard libraries. We're not importing or we're not using any specific library, and all you have to know is just Go and nothing else. Basically, as you can see, for example, we are just running some, like doing some, taking some actions. So we are just see what do we expect, what do we get when we run our function, and the rest would be literally a small if statement which everybody knows in Golang. So you don't really need to learn any other technology or library or package to run your test. Obviously there are some community packages and libraries to give us extra information, and like just for example, if you want to do BDD, you have like a simple assertion or different type of like a test description, which we will come back to them maybe in a future videos. But here all you have to know is to know Go, and you don't need to install or add any other packages and run your test. So I think if you're at this part of this video, it means you enjoy watching this one, and I will ask if you can just please like the video, because if you enjoyed it, and also if you can subscribe to the channel, that would be very good for me and for the channel as well. Thank you so much, and I'll see you in the next video.